The rapid loss of glaciers across high mountain Asia is a pressing and alarming issue that demands our attention. Recent research reveals that these glaciers are melting at an astonishing rate of over 22 gigatons of ice annually, equivalent to nearly 9 million Olympic-sized swimming pools. But here's where it gets controversial. While the role of global warming in glacier retreat is well known, this new study from the University of Utah and Virginia Tech uncovers a less obvious but equally critical factor. Shifts in the timing and intensity of the South Asian monsoons are significantly accelerating glacier melt across the region. Sonam Sherpa, an assistant professor at the University of Utah and the study's lead author, emphasizes that glaciers influenced by the South Asian monsoon, such as those in the central, western, and eastern Himalayas, are particularly vulnerable. If the monsoon's timing and strength continue to change, Sherpa warns, we could see an even faster loss of ice, which would jeopardize water supplies for millions of people living downstream. High mountain Asia is often called the third pole because it contains the largest concentration of glacier ice outside the Arctic and Antarctic. These glaciers are vital, feeding rivers and lakes that provide fresh water to over 1.4 billion people across South and Central Asia. This water supports essential activities like farming, hydropower generation, and drinking water supplies. Susanna Worth, an assistant professor at Virginia Tech and co-author of the study, points out a critical future challenge. As glaciers shrink more rapidly, the primary source of river water will shift from glacier melt to rainfall. This transition could increase the risk of droughts in downstream areas, threatening water security for generations to come. One fascinating aspect of this research is the discovery that glaciers in the southern central Himalayas actually gain mass during the summer months, not winter. At higher altitudes, the monsoon's precipitation falls as heavy snow, which replenishes the glaciers. However, glaciers retreat when they receive less snowfall or when melting outpaces accumulation. While rising temperatures directly cause more melting, they also disrupt precipitation patterns, shortening the season, reducing total precipitation, or causing more rain instead of snow. Since rain doesn't add to glacier mass like snow does, this shift intensifies melting. The consequences of accelerated glacier melt extend beyond water shortages. Rapid melting increases the risk of glacial lake outburst floods, GLOFs, which occur when water trapped behind unstable ice or moraine dams suddenly bursts out. These floods, along with related hazards like landslides and river flooding, pose immediate dangers to mountain communities, threatening lives and infrastructure. Sherpa stresses this isn't just a problem for the distant future. It's about urgent risks to people's safety and livelihoods right now. The study, published on August 1, 2025, in the IEEE Journal of Selected Topics on Applied Earth Observations and Remote Sensing, used satellite data from NASA's GRACE mission, which is sensitive to changes in ice mass. By combining this with hydrological and meteorological records, the researchers could analyze how climate warming, changing precipitation seasons, and evolving monsoon patterns influence glacier melt and the broader water cycle in high mountain Asia. Key findings include, in the central and western Himalayas, where glaciers typically grow during summer, increased rainfall correlates with greater ice loss. In the eastern Himalayas, glacier changes appear linked to decreased snowfall. Glacier retreat follows cyclical patterns every 3 to 4.5 years and 5 to 8 years, matching natural fluctuations in monsoon behavior. This raises urgent questions about how future climate-driven changes in monsoon patterns will affect glacier health over the long term. The researchers call for more comprehensive and precise monitoring networks to track rainfall, snowfall, and other climate variables. Enhanced observation systems are crucial for predicting how monsoon changes will impact glaciers and for developing effective adaptation strategies. This study challenges us to rethink the complex relationship between climate change and glacier dynamics. Are we paying enough attention to how shifting monsoon patterns might accelerate glacier loss? Could focusing solely on temperature increases cause us to overlook critical seasonal changes that threaten water security for billions? These questions invite lively debate and underscore the need for continued research and dialogue. For those interested in diving deeper, the full study is available. Sonam Fuji Sherpa et al. Investigating the influence of climate seasonality on glacier mass changes in high mountain Asia via GRACE observations. IEEE Journal of Selected Topics in Applied Earth Observations and Remote Sensing, 2025. DOI Ken.110 JSTARS 2025 3595165.